Hello, Math 3 students. This is Unit 1, Lesson 3, and this is called Functions, Yes or No. It also has interval notation in it, and then there's another thing that I'm going to add to your classwork tomorrow, so I just want to introduce that to you at the end of this video. So we are looking at functions, and the first part is, how do you know if a relation is a function or not? Let me start with, this is on page 5, sorry. Page 5. Definition of a function. Basically, we're just going to say it is a relation. It could be a set of ordered pairs or a graph or a table. So it's a relationship where each x value has or is paired with exactly one y value. And I know you've heard this before. You had this in 8th grade. Definition of domain. The domain is just all x values. And definition of range is all of your y values. And we're going to look at domain and range. It doesn't have to be a function to have domain and range. We'll look at some graphs that are not functions, but they still have a domain and range, so we'll look at that. We're also going to look at interval notation and using interval notation to state the domain and range. How can we tell if a graph is a function? It passes the vertical line test. The VLT, vertical line test. Let me move this up a little bit. How can we tell if a table of values or input-output diagram, in other words, one of those mapping diagrams, which we're going to look at too, represents a function? Each x value has exactly one y value. What I usually do is I look at all the x values, and if one of them repeats itself, I look and see if those two x values have different y values. And if they do, then it's not a function. I'll show you that in a minute. All right, moving on. Middle part of page 5. Tell whether the following are functions or not. Explain your reasoning. So if you remember, probably back in 7th or 8th grade, when you were doing pre-algebra, you looked at different graphs and you did the vertical line test. Vertical line test just states that if I can draw a vertical line anywhere on a graph and it touches that graph in more than one spot, that thing is not a function. So this one right here, the answer is no, it's not a function, and they say explain your reasoning. It fails the vertical line test. All right, so the next one, part B. Also not a function because I can draw a vertical line here, I can draw a vertical line here. There's so many places I can draw a vertical line on this one that it touches more than one place on that vertical line. So again, answer is no. Same reason, fails vertical line test. This one right here, let's see if I can, I can't move it down. This one right here, this is the graph right here, and it actually does pass the vertical line test. And so the answer here would be yes. And then you can write passes vertical line test. You don't have to write that. So the answer to this one would be yes, this is a function. A little further down, we've got D. This is a table of values. Again, what I do is I look and see, okay, are there any x's that repeat themselves? So the 5 and the 5, if there's two x's and they each have a different y, like if you had a negative one here, I would say yes, it's a function. Don't know why they would repeat that. But because these two x's both have it's the same x, sorry, and x has two different y values, then the answer would be no, it is not a function because this has two y values. Part E, I don't have any x's that repeat themselves, so the answer is yes, it is a function. And then part F, and I'm in the way of part F. Let me see if I can move myself here. There we go. Part F, let's see, I do have x's that repeat themselves. So let's see, keep up with my pen. So there's a 0 here and a 0 here, and they have two different y values, so the answer is no, that is not a function. All right, part G. Again, I'm looking for the x values to see if there are any that repeat. There aren't. This is a function. And then this is one of those mapping things, the input-output diagrams. So I have an x that's 6, and it points to 2 different y's. So the answer is no, this is not a function because this 6x value has more than one y value. All right, down at the bottom of page, I'm sorry, that was page 5. Page 6, let's move on to page 6. So interval notation. Interval notation is that thing where we use parentheses and brackets to talk about what part of a graph is included in the graph and what part is not included in the graph. So 2a, if I'm looking at x is greater than 4, well, let's draw a number line just really quickly. Let's just draw a number line. And if this is my 4 right here, well, the part that is greater than 4 is from 4 to the right. Color this in or whatever. But 4 is not included because unless it has this equals to on the bottom, the 4 is not included. So that's why I did that open circle there at the 4. And the way I would denote that, first of all, let's talk about this. It starts at 4 and it goes to infinity. You can draw your little infinity like that. I'm terrible at it. I usually draw 2 little circles. Infinity always has parentheses. But the numbers that we put in interval notation, we have to decide whether they have parentheses or whether they have brackets. So it's either going to have parentheses or it's going to have these brackets like this on one side or the other. It could be a combination of the two. It could be parentheses here and parentheses on the left, brackets on the right, or vice versa. The 4 is not included. Parentheses is what denotes that something is not included in the graph. So parentheses would be not included. You would have an open circle. So that's what parentheses denotes. Brackets denotes that a number is included in the set of numbers. And for brackets, you would see a closed circle. Or, just that line going through it. But on a number line, you would see an open circle or a closed circle. All right, let's talk about B. On B, we do have the equals to symbol. So this is less than or equal to. And if we drew a little number line again, we're not going to draw a number line for everything, but just to show you, if this is our -2, we would have a closed circle on this one. And then it would be everything to the left. It's going to match the arrow. If this is an arrow, if this is an arrow, the part that you color in matches that arrow. Okay, so this is negative infinity. This is going towards negative infinity. Infinity and negative infinity always have parentheses. And it goes from negative infinity up to the -2. In this case, I have a closed circle, also meaning that the -2 is included in that set of numbers. So in this case, I'm going to use the little bracket. Okay, this little number line is part C. I don't know how well you can see that, but this is what it's supposed to look like. If you want to redraw it, you can, or you can just look at mine. In this case, we have 2 different intervals, and they are joined by this little symbol that looks like a U. It basically means and. It means that, actually I take that back, it means or. We use the word or for this. Because it could be this part over here, or it could be this part over here. If you had if we said and, we would use a different symbol, and then it would be nothing because you can't have less than 7 and greater than 11 at the same time. So we just take this in different parts. So let's look at this part right here. This part goes from negative infinity up to the 7. The 7 is not included because you see there's an open circle right there, so we use parentheses for that 7. And then we have our little symbol here. And then it starts back up at the 11, and it goes to positive infinity. That's always going to have parentheses. This one has a closed circle, though, so that means the 11 is included in that interval, so we would use a bracket instead of parentheses. All right, let's just practice a little bit. Set notation is where you have the little, the squiggly, looks like a parentheses, but not exactly. So this set notation reads x such that line right there, that's how we say that. So all values of x such that -3 is less than x is less than or equal to 8. Let's look at the number line first. Okay, so let's draw a number line. And on this end, let's put our -3. And then on this end, let's put our 8. Okay, so what this is telling me, because the x is in the middle of these two things, is telling me that this includes everything that is between -3 and 8. So if I was going to color this in, you can color it like this, you can just make it bold, whatever. What I have to decide, though, is do I have an open circle or a closed circle at each of these? Well, this says that -3 is less than x. Doesn't have that that line under it, which means equals, that is also equal to. So this is going to be an open circle at -3. This one tells me it's going to be a closed circle at 8 because 8 is included. Okay. Now what I need to do is interval notation. Well, this is not one of those where I've got things at either end of the number line. So this one is just -3 to 8. The -3 is not included, so that's parentheses. The 8 is included, so that's brackets. And that little negative looks terrible. Let's see if I can fix it. Okay. Okay, so this one we're looking at interval notation, and we need to do set notation, and we also need to do a number line. Let's do the number line first. I think that's easier. The fact that I've got two different intervals, and they're joined by that or symbol that I usually call it like a U. It just looks like a U. Because they're joined by that, okay, so I just take these intervals separately. I've got, let's see, the 4 here, and the 9 here. And so one of these, this one goes to -infinity. Use my highlighter. It's being slow. Okay, so this one goes to -infinity. And then this one goes to +infinity. So that's what you would highlight or color bold or whatever. The 4 has a bracket. That means it's included. So it gets a closed circle. The 9 has parentheses. It is not included, so it gets open circle. Okay, so set notation. I need my little squiggly thing right there. And my first interval is going to be x such that x is less than or equal to 4, because it's got that closed circle. And then I use the word and. X is greater than 9, and then I just close that little bracket thing, little squiggly bracket. Okay, so I'm looking at this, and this is what it has on my key, but I want you to change this and. Change it to or. Because if it was and, you can't have both of those at the same time. You can't have less than 4 and greater than 9 at the same time. So we're going to change that to an or. Because you could have less than 4 or greater than 9. So we're going to change that to or. I'm not sure why it said and on my key. Okay, the next one is one interval, and it's everything that's less than 3. So let's do this interval notation first. So that's going to be parentheses, -infinity up to 3, and 3 is not included, so that would be parentheses. And then our set notation would be x such that x is less than 3. So it's everything less than 3. All right, I'd encourage you to just pause your video and try this one real quickly. And then come back to it. So go ahead and pause and try this last one by yourself, and then hit play again. Okay, so hopefully you tried this one. You're given set notation. Let's draw our number line first. That's what I usually like to do. Okay, this says x equals 7. Guess what? That's just a closed circle at 7. That's all that is. And then our set notation would just be a 7, because it's not an interval from 7 to anything, or from -infinity to 7. So we would just have a bracket around the 7. Okay. Okay, so we just have a few graphs left on pages 6 and 7. And our directions here are to state whether it is a function or not, and then to state the domain and range and interval notation. So 4a. This, of course, is a function. It's a linear function. It passes the vertical line test. The domain, this is the parent function for a linear function. The domain is all real numbers. What I would like for you to do, though, is interval notation, negative infinity to positive infinity. All real numbers also works, but it asks for interval notation. So range, same thing, because all the x values are represented, all the y values are represented. So the next one, B, this is also a function, so we would answer yes, function. Domain, the x values, they go forever, to the left and to the right. So for domain, that would be negative infinity to positive infinity also. The range, on the other hand, goes from here to here. So it has a maximum and a minimum. And let's see, it's kind of hard to see. This is, yep, that's -2 to +2. So, and those are included, so we're going to do brackets, -2, +2. All right, for C, this is a function also. It passes vertical line test. It looks weird, but it's still a function. The domain here, it goes forever to the left, forever to the right. So domain is negative infinity to positive infinity. The range, it does come from negative infinity, so we can put that first. But then it stops at, what is that? 1, 2, 3. Yeah. Even though there's no line right here, that's the 3 line. Mine says 4. Why did it say 4? Oh, okay. Never mind. Here's the x-axis. This looked bold. I thought that was the x-axis. So 1, 2, 3, 4. Let me change that. So it stops at 4, and 4 is included. So that's a bracket. All right, for D. This is a function. Even though it's just a horizontal line, it still passes vertical line test. Now, if this had been a vertical line, the answer would be no. Domain goes forever in both directions, has arrows at both ends. Negative infinity to positive infinity. The range is just -4 because it's a line at y equals -4, so the only y value is -4, and that has a bracket. For E, this is not a function, so the answer is no, it's not a function. It fails vertical line test, but it does still have a domain and range. The domain, if you notice, it has like a block. That's the same as like a closed circle there and there. So the domain starts at -5 and it stops at +1. So x equals -5 and x equals +1. Those are both included because that block is there. That, again, that's like a closed circle. And then the range also stops. It starts down here at -4. And it stops at y equals 2. And again, they're both included. So, all right. For F, this is a function. So you would answer yes, it's a function. This one has open circles. So we have the domain starts at x equals 2, ends at x equals 3. And these both have parentheses because they're open circles, so 2 is not included in the graph and neither is 3. The range starts at y equals 1, ends at y equals 3, and again, parentheses because they're not included. For G, why don't you try this one, pause your video, and I don't know if you can see this one very clearly on your notes because it looks really bad on my paper version, but this is what it's supposed to look like. So you got open circles here. Pause this one and try it real quick, and then come back to the video. Okay, so you should have paused your video and come back. The answer is no, it is not a function because it does not pass vertical line test. It does have a domain that starts at -2 and ends at x equals 4. The -2 is included. Oops, sorry, that's in the wrong place. The -2 is included, the 4 is not, so that's parentheses, brackets on one side, parentheses on the other. The range, that shouldn't be there. I meant to put that around the -2. The range starts at y equals -4, and ends at y equals 3. Those are both open circles, so they both have parentheses. So I'd like for you to pause the video again and try this one. I want you to notice that there's an open circle down here and there's a block here, and it's between 2 and 3. So try this one and then come back. Okay, so this is h, and this is a function. It passes vertical line test. The domain starts at x equals -4, ends at x, I'm going to say 2.5, 2.5 is fine. The -4 is not included, and the 2.5 is included. And then the range starts at y equals -2, ends at, I think that's a 3, yep, ends at y equals 3, the -2 parentheses, and the 3 brackets. All right, so I'm going to leave those last 3 for you. This one's a little tricky. I want you to really pay attention to the range on this one. The domain's a little bit easier, but the range is a little tricky. So I want you to try these, and then when you come to class tomorrow, we will go over those together. So you're going to receive a sheet that looks like this with your classwork, and I just wanted to show you what it looks like on Desmos. So it's a Desmos activity, so you're going to type this in, and I mean, you can go ahead and go over there. You can type this into your browser and go on over there if you want to, but I want to show you what it looks like. So when you type in that address, or you can also go to the link that I'm going to put on Planbook, you will come to a Desmos page that looks like this, and then your sheet that you're going to have looks like this. Sorry. So what you're going to do, let me scroll down here. There are 7 files to help you review the functions you've learned in Math 1 and Math 2, and some of the ones that you're going to learn in Math 3. You're going to open the file one at a time to review the equation, graph, and key features of each function. And then you're going to adjust the sliders. Let me just show you what you're going to be looking at. Let's see if I can, there we go. Okay. So let's start with linear functions. So if we click on this little arrow here, this is the linear function right here. Of course, linear parent function is y equals x. But you could have some different values like this m here and the a and the b that change some things around. So what you need to do first, though, is make it visible. So on Desmos, if you have this this circle right here, that means that graph is not visible. And so you can make it visible. You can go make all of them visible if you want to, but just it's probably better if you just do one at a time. Okay, so put my phone on silent. So if you look at the m, for example, and you start using this slider, if you use this slider and change the value of m, you notice what it does. It changes the slope, because of course the m is the slope in slope-intercept form. And so as you move that that slider and make m bigger, you see the slope changes, and then as you make it smaller, it goes toward a horizontal line. When you get to 0, it is a horizontal line, and then when it's negative, it starts changing to the negative slope. What you can also do is you can also hit this little play button right here and see it change as the slider moves on its own. Okay. Then what we want to look at is the A. Okay, so what does the A do? So you see it moves it kind of from left to right. So it moves the graph that way. And then the B really is moving it up or down. It's changing the y-intercept. It's just hard to see. If you let's make the M closer to 0. Let's just put it right there. Now let's move the A. So what is the A doing? It's moving it. B, same thing. Okay. So then you go back over to your sheet and you state, you fill these things in. So linear function, I want you to write, oh, actually, no, you don't have to do that. You can sketch it. You can talk about the shape of the graph. You can sketch it right here. So let's just sketch, linear function. Okay, straight line. M, what effect does that have on the graph? It changes the slope. You can say it changes the slope. That's fine. Term 2, that's the A. What effect does that have? Term 3, the B. What effect does that have? What's the shape of the graph? It's a line. What's the maximum number of x-intercepts or real roots? And what's the minimum number? Well, a line, hold on, get back over there. So how many roots is it going to have? Well, it's going to have 1, unless it's a horizontal line, and then it's going to have an infinite number. So the maximum number of real roots would actually be infinity, because it could touch it everywhere. The minimum number of real roots is at least going to have 1. Okay. Maximum number of y-intercepts, it could have an infinite number of y-intercepts if it's a vertical line, right? It's a vertical line, it's not a function, but anyway. Minimum number of y-intercepts, it's always going to have at least 1. So anyway, that's what that looks like. I just want you to do, here's the next one. Oh, I thought I put it up there. Okay, a quadratic is the next one. So the next function that you would look at, make that one invisible, bring that back up, look at the quadratic, make it visible, move some things around again, move the C around, see how it gets skinnier and fatter. That's kind of the way I look at it. Also, when it goes to a negative, it opens down, opens up. So I just want you to do a little discovery, just a little exploring on this, and fill in that sheet. And this is something that you're going to have on your classwork tomorrow. So you're going to fill in this sheet as you go. So I really just wanted to show you what it looked like and kind of how you're going to look at it and fill in the that sheet as you go. So that's it for today. Let me know if you have any questions. See you tomorrow.